Differentiation by first principles actually comes up fairly regularly on the higher paper, and it's quite a decent question if you know the steps involved. I think the best way though to avoid making careless mistakes in questions like these is to break down your solution into separate steps. So I've outlined 4 steps here in this table for approaching these differentiation by first principles questions. So maybe if you want to pause this video and take this down as notes, do so now, but I'm going to go straight ahead and do 2 worked examples using this step-by-step approach, and hopefully you'll see how straightforward these questions are. Alright, so the first example I'll do is of a linear function. The higher level syllabus currently requires that you can use first principles to differentiate just linear and quadratic functions, so I'm just going to do an example of each of those in this video. Now, before we go into our step-by-step approach, I just want you to have a think about what our final answer will be. What is the value of f-x going to be in this particular example? Remember that when we differentiate a function, we're basically just finding a slope. So here we have a linear function with slope minus 5, because minus 5 is the coefficient of x, which is always the slope. That means that the derivative of this function is a constant value of minus 5. Now, if this came up in a Leaving Cert exam, you would not be able to just write down the final answer, even if you spotted that. You would have to go through all of the steps to get the full marks. So let's go through those steps now. Step 1 is to take your function and replace x with x plus h. Basically, that just means we're finding f of x plus h. So we have minus 5, and instead of x, we write x plus h, and then plus our constant of 4 at the end. Now I'll simplify that by multiplying out the bracket, giving us minus 5x minus 5h plus 4. And we can't simplify that any further, so we go on to step 2. In step 2, we take our answer from step 1 and subtract our original function. So we take our minus 5x minus 5h plus 4 and subtract our original function, which is minus 5x plus 4. Now we want to simplify that expression, but we just have to be careful with this minus in front of the bracket here, because that's going to change the sign of everything inside the bracket. We have minus 5x minus 5h plus 4 plus 5x minus 4. And now some of these terms cancel. The minus 5x cancels with the plus 5x, and we also have plus 4 and minus 4. That means we're just left with minus 5h. In step 3 then, we take our result from step 2 and we divide by h. So in this case, we are taking our minus 5h from step 2 and dividing by h, which just gives us minus 5. The final step is to take the limit of our expression that we obtain in step 3 as h approaches 0. So just to write that step out in full, it's the limit of f of x plus h minus f of x all over h. Now what we got in step 3 was a constant of minus 5. And minus 5 as a constant like that doesn't actually depend on h at all. Usually in this step, what we do is we would sub in 0 for h, and that would be the limit of the expression as h approaches 0. However, we don't have any h's, so our final answer is just minus 5. And that is what we expected. It's the slope of that linear function. It is the first derivative with respect to x, differentiated by first principles.